Hey everybody, Raghav here again. Today I'm back with another video. This time we are not going to talk about COVID-19 dataset. Let's park it for a while. Today I'm going to cover another fun topic in data science, which comes from the NLP world, which is natural language processing. Specifically, we will be covering named entity recognition today. Before we dive into anything about named entity recognition, I would like to show you an example of what we are going to do. So just take a look at this sentence. It says Apple acquired Zoom in China on Wednesday 6th May 2020, which is not a true statement, but I made it up just to show you an example. Here, our goal is to find out which are the named entities in this sentence. So by named entities, I mean words representing real-world entities. For example, Apple, a company; Zoom, a company; China, a location; Wednesday, a day; 6th May 2020, a date. So all these words are named entities, and in this video we are going to cover algorithms which will help us identify these named entities automatically in a given text. Now, after seeing this example, you might be wondering, what is named entity exactly? So a formal definition that I made is any word which represents a person, organization, or a location is a named entity. There could be other named entities like dates, addresses. So those are all covered in named entities. It is a subtask of information extraction and is the process of identifying words which are named entities in a given text. You can also call it entity identification or entity chunking. And before we dive into the code, let me tell you why it is important. So you do NLP to understand the meaning from a given text, right? So in order to do that, you need to understand who did what to whom. And in order to do that, you need to find out what are the named entities in that particular text, so that your task of identifying who, what, and whom is made easier. So this is probably the first step in analyzing the meaning from a text in your machine learning pipeline. I would also give you a caveat that no algorithm is 100% accurate. Even humans can't identify named entities correctly. The current human accuracy is around 96%, and a machine algorithm based accuracy is around 93 or 94%. So that's the state of the art. But today we will cover three approaches. One is a basic NLTK algorithm, which is quite fast and easy to implement. Second is Stanford NLP NER, which is slightly better than the NLTK algorithm, but is a little bit of pain in setting it up and getting it running. And third, which is my favorite, is using Spacy library. So I'll discuss all these three and how you do named entity recognition in this video. And without any further ado, let's get started and dive into the code. So first of all, let's import all our dependencies for the NLTK approach. So we need NLTK and pandas. This is our example text. I have here Apple acquired Zoom in China on Wednesday, 6th May 2020. This news has made Apple and Google stock jump by 5% on Dow Jones Index in the United States of America. This is not from a real article, I just made it up, just to give some complexity to the algorithms. So our first approach is using the NLTK. In NLTK as well, I have divided into two parts. One is a word-based approach and the second is a sentence-based approach. So what I mean by word-based and sentence-based approaches is, if you see here, I'm tokenizing the text into words first. So I'm breaking down the text into individual words. That's the word-based approach. In sentence-based approach, I will first tokenize the text into sentences and then I'll do word-based tagging on it. So the idea is sentence contains a sub-meaning of the whole text. So doing it sentence by sentence makes more sense in some algorithms and might be better for you when you train it on your domain specific data. So it's up to you. You have to try out various methods and see which one works better for you. So let's continue with our word-based approach using NLTK. So this step is clear. You're tokenizing the words into, you are tokenizing the text into words, and then you do a part of speech tagging using pause_tag function in NLTK. It will label each word, whether it's a noun, a verb, injunction, and whatever these words mean. I even don't know. What I use is this function to check what each code means. So if you pass in N and P, you will get noun proper singular, right? So apple is a noun proper noun, and that's what it says here. The next step in this approach is to use the function called any_chunk, and it is applied on the part of speech tags. And there's another parameter that you pass is binary equal to true or false. So binary equal to true will give you just two outputs. Either the word is named entity or not. But if you give binary equal to false, it will have multiple labels. So it will have a person, organization, or a geopolitical entity. So based on your application, you can use any of those values. I will show you both the approaches and what results you get. So in this approach, I am getting the chunks from this function and then I'm printing all these chunks. So you see Apple is identified as named entity, China is identified as named entity, then Google is identified as named entity, and United States is as well identified as named entity. So in this cell, I'm just taking out all the text and the labels and putting them in a data frame. So this is what this algorithm has identified as the named entities, and you see that it hasn't identified Zoom as one of the entity, and the United States of America as well. The United States is there, but of America is missing here, right? So there are some misses. As I said, none of the algorithms are 100% correct, so they might miss something. That's why I had that sentence in the beginning, which can, give some challenge to the algorithms. Okay, so the next cell shows you with binary equal to false what you get as an output, and you see here that Zoom comes in as a person and America as well as GPE. So you get more labels here. You get organization, GPE, or a person, but all in all you're getting all these named entities from that sentence, from that text, right? So if you don't care about what label it assigns and you just want to know what are the entities being talked about in the text, this is a good way to get those. The next approach is sentence-based. So here, instead of doing the word first, we tokenize into sentences, and then we tokenize the sentence into words, and then do the chunking. And based on this, if you compare the results, it's exactly the same. So nothing has changed here, right? So you got 7 entities here and 7 entities here as well. But in some cases it might give you better results. This was a very small text, so it might not show the difference, but you can try this when you're training it on your domain specific data. Okay, that covers the NLTK based approach. The second approach is using the Stanford NLP NER package, which is located on this link, and this is a good blog to read before you start installing it. There are some steps that you need to take to install it on your machine. I'm using a Windows computer here and it talks about Windows. Maybe on Mac it would be simpler, so you can play around and search on Google how to install it. I can say that I was having some problems with setting up environment variables and then reading the model and jar files, so I just gave the hard-coded path to these two files, which will be used in order to create this object Stanford NER tagger, which is a package in the NLTK.tag module. And you instantiate this Stanford tagger with this function, and then you tokenize the text again into words, and then you tag it using this tagger, and after that you just extract what it has tagged and put it into a data frame, and this is what it gives you as a result. As you can see, it tags all the words. O means other, and the words which it has not been able to tag, it will mark it as O, and the others, you can see Apple is a location, Zoom it missed, China is a location, the dates again it missed, Google is an organization, which is actually correct. Then you have Dow Jones Index, it didn't identify that, and United States of America is being identified as 4 separate tags, which we can fix because the Stanford package doesn't take care of combining these entities into one. This cell over here does that job. It just groups by all the classified text which have the same consecutive location and are identified with the same tag. It will join them together, and then if you create the data frame, you will see United States of America is being identified as one single entity. And I am selecting only the labels which are not equal to O, so you are getting just these 4 labels out of the Stanford NLP tagger. So you might say the Stanford NLP tagger is performing even more poorly than your NLTK. But if you see, Apple and Google are both identified as organizations, and China and United States of America are both identified as locations. So you can say it's more accurate, and it still depends on your application and how you are training the models for your dataset, and you can definitely try which one works better for you. So that covers the Stanford NER package. Now third one is my favorite one, which is using Spacy library. Spacy after their 2.0 release is wonderful. It is fast and it is more accurate, and I couldn't recommend it enough that you download it or upgrade it as soon as possible. So this is what the dependencies are for Spacy. You will have to download the Spacy language model. There are 3 different versions available. One is the small, second is the medium, and third is the large. It all depends on the complexity of the model. So they use deep learning to train their models, and small model is a small neural network model which is less in size, and medium is slightly bigger than that, and large is really large. And what I have seen from their website, the accuracy on the named entity recognition task is almost same for all 3. So I'm going here with the small model because it's fast and it takes less memory and CPU when you run it. Right, so this is how you load it. For the first time you will have to download it with this command that you can uncomment and run. And now to how to perform the named entity recognition task using Spacy. So first step is to convert the text using this NLP model that we have created into a doc, and then it will have all the entities in this object. You just select them out using a for loop, add all the entities to the entities list and labels to the labels list, and you can also get the position start and position end values as well, so where the word starts and ends. As you can see here, Spacy does a very good job of identifying all the named entities in my text that I've given. I don't think it has missed any of those. The only thing that it has probably not performed so well is that it hasn't identified Zoom as an organization. Maybe Zoom is so new that their model needs to be trained again on whatever dataset they used to train it on. and if they do that, it will definitely identify it as an organization. So all in all, I think Spacy does a wonderful job. It even identifies the date. It also gives you how much percentage. So it's wonderful. I just can't recommend it enough, guys. So you should try it if you haven't. And this function is very handy to understand what these labels mean, so you can use that if you want. And that's the end of this third approach as well. I hope you have learned something new. Now what you can build with this is a lot of stuff where you need to act upon reading text. So a bot that can analyze financial news and extract information about the entities and the numbers that are being mentioned in that, which can be further utilized in building an algorithmic trading bot. Or you can analyze research papers produced every day on COVID-19. There's even a Kaggle competition on that where you can use it and find out any significant developments in that. So it's up to you how you use this knowledge. I'm very thankful to you for listening to me talk about this topic. This is something which is very useful, I believe, and it might be helpful to you as well. If you have found this video helpful, or if you like this video, please do hit the like button, and if you have any comments, any feedback, please let me know in the comment section. If you just want to have any conversation with me, you can follow me on Twitter. My Twitter tag is DataRaga. I'll also put it on the description below. I have other videos which you can watch which talk about visualization in Python and even some tutorials on R. I'm just getting started, so please bear with me if I'm making any mistakes while recording this session, and hopefully I'll get better in every video that I make. And thank you for listening, and keep safe, and see you in the next video. Bye bye.